maybe to. And secondly, after that big issue, I would like also to address in proposing the solutions that I mentioned previously. We are demanded not by government policy, not by the economy, but by our environment, by our very planet that we live in, to do the solutions, to deliver the solutions by sustainable means. What I mean by the sustainable is the environmental sustainable. So the Habitat for Tomorrow is not only affordable, resilient, and adaptable, but also long-lived. Thirdly, besides the theme itself, a bit out of the conference context, but maybe relevant to the fellow researchers and academics from universities from Indonesia around the world as well. HABITechno7 this year jointly organized with the Visaca from University of Udayana. Thankfully, Udayana is very open for the collaborations and very helpful during this event, the preparation as well. We couldn't get a better first collaborator for HABITechno than Udayana, so thank you, Bu Anggi, Bu Dekan, Pak Rektor. What I want to highlight is, in the past few years, architectural academic conference, specifically architectural conference, not the whole scientific conference in Indonesia, has seen a declining number of participants if we do it by ourselves. Every university has conference, and the number of researchers they are targeting are the same. So every year there are maybe more than 10 conferences in different months. So we think that by joining similar team, conference with similar teams, can be more resource efficient in terms of human resource and also financial resource, as well as the discussion will be maybe more fruitful because the HABITechno traditional researchers that presenting papers will also combine with Udayana, the Visaca presenters. So with so many architectural conferences conducted every year by every major university in Indonesia, major and minor university in Indonesia, and the fact that we are inviting the same researchers, so isn't it better just to maybe some conference, 2 or 3 of them joins, and we can make it a bigger conference with more efficient resource. Finally, on behalf of the entire organizing committee of ITB and Udayana, I thank you all for participating in this conference. I thank you again, Pak Fahri Hamzah, for attending this conference. Hope you can get insight from our keynote speakers, and if you may attend the parallel sessions as well. In the program book, you can see the titles, and there's an abstract link for the papers as well. And with that, I'll conclude. Thank you for your attention. Good morning.
Thank you, Dr. Suhendri. Next, we are honored to welcome the Rector of Udayana University, Professor Ketut Sudarsana, to deliver his remarks.
Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Namo Buddhaya. Rahayu, good morning, everybody. His Excellency Vice Minister of Housing and Settlement Area, Republic of Indonesia, Bapak Fahri Hamzah, SE. Such a great honor for us to have you here, Pak Wamen. Welcome to Udayana University. The Honorable Director of Settlement Area Development, Minister of Housing and Settlement Area, Republic of Indonesia, Bapak Insinyur Edward Abdurrahman, MSc, Head of Department and Agency of Bali Province, the Honorable Head of Department and Agency of Denpasar City and Badung Regency, Dean of the Faculty of Engineering Udayana University, Dean of the School of Architecture, Planning and Policy Development Institute Teknologi Bandung, Head of Ikatan Arsitek Indonesia, Head of Aptari, IPLBE, and Eco Mantra, Honorable Heads and Coordinators of Study Program, Architecture, Udayana University, distinguished speaker, esteemed guests, researchers, scholars, and industry leaders, as well as students. Ladies and gentlemen, welcome to Bali. Welcome to Udayana University. It is my great pleasure as Director of Udayana University to welcome you all to HABITechno and the Visaca International Joint Conference 2025. We are deeply honored to co-host this significant event alongside Institut Teknologi Bandung and Warmadewa University. This year's themes, Habitat for Tomorrow, Affordable, Inclusive, and Sustainable Living, is not only timely, but deeply aligned with Udayana University's own vision to become a superior, independent, culturally grounded, and globally competitive university. In an area of rapid urbanization and environmental uncertainty, our responsibility as academics extend beyond research and education. It is to shape future to balance innovation with local wisdom, sustainability with inclusivity, and progress with cultural identity. The Visaca, as part of this joint conference, represents our continuing effort to integrate architecture, cultural heritage, and community empowerment. What began as a platform for exploring tourism and visual colonial architecture has evolved into multidisciplinary dialogue on how the built environment reflects and transform our social and cultural reality. Through Visaca, we reaffirm Udayana's role as a bridge between traditional Balinese knowledge and global architecture discourse, where heritage becomes a foundation for innovation rather than a relic of the past. The honorable audience, today's collaboration between HABITechno and the Visaca is more than an academic partnership. It is a living example of what exclusive and sustainable development look like in the practice. By combining ITB's excellence in building technology with Udayana's cultural and regional expertise, we aspire to demonstrate how design, science, and community participation can together respond to the challenge of climate change, affordability, and social resilience. At Udayana, our mission emphasizes three Dharma perguruan tinggi: education, research, and community services. This conference embodies all three: knowledge sharing, collaboration, actionable outcomes. I hope that the ideas exchanged over these days will not remain within these walls, but extend into our policies, communities, and the next generation of architects and planners shaping Indonesia's sustainable future. As we open this joint conference, I express my heartfelt gratitude to our organizing committees, academic partners, sponsors, and supporters, including the Ikatan HABITech Indonesia Bali chapter for their dedications to realizing this vision. Let this gather reminds us that a sustainable habitat begins with a sustainable mindset, one that honors the past, serves the present, and safeguards the future. Once again, welcome to HABITechno, the Visaca International Conference 2025. May this event inspire knowledge, creativity, and collaborations for the betterment of our shared habitats. Thank you. Om Santi 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 Om. Wassalamualaikum warahmatullahi wabarakatuh. Salam, namo buddhaya, salam kebajikan, salam sejahtera bagi kita semua. Rahayu, rahayu. May peace be upon us all. Thank you.
Thank you, Professor Ketut Sudarsana, for the remarks. Now we are honored to welcome the Vice Minister of Public Housing and Regional Settlement, Mr. Fahri Hamzah SE. He will deliver his keynote address and officially open the 7th International HABITechno Conference in collaboration with Visaca.
Thank you very much. Actually, I would like to explain some topics that I present in a very important meeting in the OECD Secretariat in Paris just 2 weeks ago, but because the committee only given me 15 minutes, so I would read something here written by our ministries. Terima kasih Bapak Ibu sekalian. And the rector said, you must speak in English because everyone is in this room speaking in English. So I will be deliver some short speech here in English. And let me, if I have more time, I can explain some of the design of the government policies regarding housing in settlement. The Honorable Rector of Udayana University, Sudarsana, Professor Sudarsana, Board of Advisory Scientific Committee, okay. Nah, terima kasih ya. Also from HABITechno ITB, Dr. Alice, Scientific Committee, distinguished speaker, guest, participant of HABITechno7, ladies and gentlemen. Good morning, everybody. Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. First of all, let us express our gratitude to Almighty God, as only with the blessing we are all be present at this multi-stakeholders conference to address global challenge in habitation. I'm very honored to be invited to deliver a keynote speech since the conference theme is very relevant to our ministerial responsibility. Ladies and gentlemen, in brief, currently, the Ministry of Housing focuses on delivering better houses and settlement in order to tackle housing backlogs and slums in Indonesia within the framework of 7 million houses program. Let me explain later what is the 3 million housing program. Kalau bisa ditaruh itunya yang bagan langsung ya. Working with the stakeholders, we aim to provide more inclusive, affordable houses improve low-quality houses, especially those owned by low-income people, and build sanitation facilities and other basic infrastructure to reduce slum area, to ensure the development are suitable to the specific communities' characteristic. We divided the program into 3 regions. They are urban, rural, and coastal region. However, to speed up the development effort, the ministry need your research-based knowledge and technological innovation. Some of the area we need to collaborate at. Number 1, creating database and planning system for housing using advanced technologies such as artificial intelligence to collect and update the housing needs dynamic, leveraging the local and environment-friendly material for housing and basic infrastructures, developing appropriate technology to improve housing resiliency to the natural disaster, and reducing the carbon emission from housing sectors. Furthermore, we also realize that housing and settlement development has a significant contribution to boosting economic activity and providing jobs. Regarding this aspect, I also encourage all of you to explore more recommendation and work together with us doing some empowerment activities to stimulate small-scale housing industries to produce local low-cost carbon materials. Ladies and gentlemen, this is the bagan yang struktur terus. This is the whole structure that the government want to implement and already budgeted with the national budget 2026. The whole idea of the president to promise to the people of Indonesia to build 3 million houses per year is to build 1 million, build and renovate 1 million in the rural area, 1 million in the coastal area, including the slum, and 1 million in the city or urban area. The 3 million programs will be funded by different source of income, source of money. The rural program will be 100% funded by the national budget. It's already in our budget that we will be starting with 400,000 houses renovation next January, which covered by 8.9 trillion rupiah money taken from our national budget. But we plan 1 million, but the president or the Ministry of Finance giving us 400,000 for the initial starting. So if we can implement, find the technology, find the ways and the mechanism that making sure all of these development or renovation would be suitable to all the standard that we have, the government can increase the number, not only 1 million, but probably for the renovation will be taking more than 1 million, probably until 2 million, because the under standard backlog of housing in Indonesia cover more than 20 million families of Indonesia living in under standard housing. So 10% would be 2 million per year. That is our target, and we'll be starting with 400,000. The second one is the program in the coastal area, which will be covered, everyone or every family of Indonesia living on the coastal area. We're working together with the Ministry of Marine and Fishery also to renovate the house and the settlement of the fishermen. So the coastal area of Indonesia will not be only becoming a center for the protein, but also can becoming a very important location. I urge the Ministry of Fishery, Marine and Fishery to name it as the creating 1,000 Maldives every year. So probably Bali could be becoming one of the target of this project, since so many people living in the coastal area in Bali, and Bali is a part of our tourism destination. And the last program would be the building 1 million vertical housing in the urban area. This will be taking from not only from the national budget, but national budget could become the guarantee. Especially in this system, we will follow the system of HDB in Singapore or TOKI in Turkey. So there will be two institutions developed in this program. Number one is the housing queue will be taken care by Tapera. This is our national saving for the housing program. And all the queue will be going to Tapera, as long as you are, pay the down payments, and you will become in the list of those who are eligible for the national housing program, especially in the urban area. And the second one is we created what we call as the national housing logistic. One of the oldest state-owned company named Perumnas will be appointed as the national logistic for the housing. So all the vertical housing built by the construction company or the developer will be absorbed by this institution, the Perumnas, and can deliver to those who already in the housing queue. So this is the future of the Indonesian housing policies. We know that this is very big, and we are invited with so many international institutions to explain, because housing development today is not only the demand for every family and individual, but also impacting some issues, including the environmental issues. That's why we will make sure that the delivery and the development of the 3 million housing will also cope with the concept of habitat for tomorrow, which in the vision of green, energy efficient, and also zero carbon emission and resiliency. So this is the idea, Pak Rector, and all the guests, especially those who coming from abroad, from universities, from the academics. So we need your help with working together with us and discuss the platform for our future of the habitation. Thank you very much. Terima kasih Ibu Dekan yang sudah menjemput saya tadi malam di airport. Terima kasih semuanya. Selamat pagi. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Fahri Hamzah, SE. And next, we kindly ask to all distinguished guests to please stand up for the group photo session. We kindly ask to all the guests to please stand up for the photo group session. And for the organizing committee members assigned, please come. On the count. again, 1, 2, 3. Once again, we want to thank you for Mr. Fari Hamka. Time and come in HABITechno7.
Ladies and gentlemen, we now move into the core agenda of our conference. To start, we are pleased to invite the representative from our sponsor, PT Polimindo Viro, Mr. Jong Johan Sumardi, to deliver the presentation.
Good morning, ladies and gentlemen, distinguished guests, or as we say in Bali, Om Swastiastu. Yeah, I'm glad to have a chance today to share with you a little bit about who we are and what we do. So my name is Johan Yang. I'm Executive Vice President of PT Polimindo Permata, but we are better known by our brand name, Viro. So what is Viro? As a company, maybe we can start with the slide. As a company, we were founded in 1985. So this year, we are celebrating our 40th anniversary. I am a second generation The founder of the company are my parents. And we started in 1985 as an extrusion company. We make small precision tubing for components such as cotton swab, for ballpoint refill, things like that. Over the year, we've transformed the company, and what lies as the core values of the companies are a principle. Maybe some of you are familiar. It's called triple bottom line, or 3P. So triple bottom line means, number one, we are a for-profit company. So we have to be profitable in order to sustain our operation. But beside profit, there are two other bottom line that we pay attention to. Second bottom line is people. So we pay attention on how our operation create positive effect to our the people around us, for our employees, for our customers, for our partners, for our country. So those are the second bottom line. Third bottom line that we always pay attention also is planet, environment. No human activities is completely devoid of environmental impact. But the idea is we have to do our best to minimize our impact on our environment, negative impact on the environment. So that is the goal that we set out for ourselves. And this goes into things starting from the design thinking of our products. When we design something, we always think with the end of life cycle in mind. So we think about, how is this product going to be recycled? How is this product going to be reused? That is part of our design thinking from the very beginning. So for example, we have one of our main product is thatch panel that is used in many of the thatch roof. Next slide, please. Next. We can go maybe to the one where we see more of our projects. So with our thatch roof products, we think about how to create a product that is made from single material for ease of recycling. So all of this is part of our design thinking from the very beginning. Where does Fyro comes from? So Fyro as a brand was created in '98. And at that time, environmental issue wasn't a big issue. But my father set out to do from the very beginning. Fyro is taken from the word environment. So that's why this has always been our identity from the very beginning. Of course, standard changes over the year. Initially, when we first create Fyro, the first product is synthetic rattan that maybe many of you are familiar. If you go to cafe in Bali, you will see a lot of people sitting on synthetic rattan furniture. So that's our first product. In the very beginning, what is the concern for that product is mainly we're talking about beauty, durability. The product has to last. The product has to be able to withstand outdoor condition, and then ease of recycling. But then over the year, different things come up. In 2008, we faced a situation, maybe many of you remember, the global crisis. So as a company, we have to transform ourselves. We have to go after a bigger market. So we went after the building material industry. So we start developing products toward that industry. And in that environment, you don't only need beauty, durability, but you also need safety. That is why we create product that is able to pass building code from around the world, fire resistant code, wind test upload code, durability, weatherability, smoke density, things like that. So all of those become part of our portfolio. Now, I want to share with you maybe what are the concepts that we bring to the market and what makes it unique. Oftentimes, we often combine two aspects. On one side, we focus on technology, material science. That is our strong point. We are a material company. That is our background. So because of that, we create unique material for specific applications. When we're talking about synthetic rattan furniture, what you need is you need tensile strength, you need durability, beauty, weatherability. But when you're talking about building materials, then you need not only those things, but you need safety. You need material that doesn't easily burn, material that is able to withstand years, decades even for outdoor environment, material that can be reused at the end of its life cycle, can be easily recycled. So those are some of consideration. We also have a line that we call Viro Living. This is part of home accessories collection. So in Viro Living, we design material that is safe for food contact. You can put a piece of fruit, you can put bread, you can put food in there, and it's not going to transfer any toxic material or anything into your food. So that's become part of our design thinking. And then the other thing that we often combine is we combine culture. And this is where we have competitive advantage. We have other competitors around the world. We compete with Chinese company, we're competing with American company, Canadian company, and many other around the world. But what is unique about us is we bring Indonesian culture to the world stage. So one of the things that maybe we can show some of projects around the world. I think there's a project that is in China. This is Maldives. There's one project a few years ago. We did a project called Chimelong Ocean Kingdom. And basically that is one of the largest sea-based theme park in Zhuhai, across from Macau. And one of the things that I'm proud of is most of the time we hear Indonesian importing from Chinese company. In this case, an Indonesian company is exporting to China. So that is something that we bring because we have something unique that they don't, which is our weaving culture. And that is something that become our competitive advantage. This is one of the other project that we did. This is a project in Florida for Disney, based on the IP of the movie Avatar. And sometimes I joke that the Navi people that populate the planet Pandora, actually they live in Banten in Indonesia. So many of this is done all in our factory in Banten. And this is a lot of this, basically we combine these two things, the material science that we develop with our culture. So that becomes our strategy for competitive advantage. What's next for Viro? Right now, we are starting development into prefab modular building. So what next is we're developing the industrial base designed to help development in secluded area, light footprint architecture, things that can be assembled easily on the field. And the goal, one of it, is to foster the development of tourism industry, specifically for what we call desa wisata. Tourism we see as one of the big economic potential for Indonesia. When we look at the competitive advantage of our nation, we are the largest archipelago country in the world. And if you look at survey, for example, from Condé Nast, when people is being asked what is the ideal vacation, almost 70% of the answer would be tropical beach. That is what that's what people thinking when they say vacation. I've been to the Maldives many times because of our projects. We have more than 20 projects over there. And to be honest with you, I wasn't that impressed because the view of the Maldives is, in Indonesia, we can find what we say a dime a dozen. We have so many islands like that. But the key that we have to improve, I think, in terms of policy, as well as access, infrastructure, how to get to those locations. So now, if we can combine between public policy and private development and create pondok wisata, desa wisata in many places in Indonesia, I think it can has the potential of creating tremendous economic impact. So that's a little bit about Viro. Thank you so much for your time.
Ladies and gentlemen, we now move to the highlight of our morning program, our first plenary discussion with the title Digital and Sustainable Transition Toward Climate, Resilient and Inclusive Habitat.
But before we continue, there is a quick reminder to all participants about the QR code you already received during the registration for a brief questionnaire. And thank you for your cooperation. Now, we want to introduce the moderator who will lead this discussion, Dr. Doni Kurniawan.
Dr. Doni holds degree from Gajah Mada University, Institut Teknologi Bandung ITB, and the University of Kitakyushu, Japan. His expertise include energy, built environment, and neighborhood development. He is currently part of ITB Building Technology Research Group.
Dr. Doni will be joined by our panel of distinguished experts. The first one, Professor Suryamanto from ITB. The second one, Professor Sizan Aziz from University of Stanford, United Kingdom. And the third one, there is Dr. Eva Haulihan Wiberg from University of Florida, United States. We now invite Dr. Doni Kurniawan and all esteemed speakers to the stage.
Thank you very much. Good morning, everyone. This morning, for the session one, I would like to invite Professor Suryamanto to come to the stage, and Professor Siza, would you come to the stage? And I think there is a Eva for this. For the third presenters, unfortunately cannot come to in person today. She will be presenting online. Okay, before we start in the sessions, I would like to introduce what kind of topics of the first sessions. So today's sessions focus on three interconnected pillars: technology, regenerative architectures, and the community empowerment. We are living in a time when buildings are no longer just shelters. They are interface of data, ecosystem of energy, and platform for social collaborations. As we face climate urgency and rapid urban transformations, architecture must be on minimizing harms, and it must restore, revitalize, and regenerate our natural and social environments. So regenerative architectures remind us that sustainability is not the ceilings, it is the floors. Technology provides the tools from digital fabrication, sensor and AI to biomaterials and circular systems and community empowerment that ensure innovations in inclusive, contextual, and human-centered. In these sessions, we will learn how this element converge, how technology can amplify local wisdom, and how design can heal ecological systems, and how communities can become co-creators of our own resilient futures. So we are privileged right now to have with us today outstanding speakers and practitioners who are actively pushing the boundaries and redefining what architectures can contribute to the society. So I would like to introduce for the first presenters today, Professor Suryamanto Wonoraharjo is a professor at Institut Teknologi Bandung and head of the Building Technology Research Group. His expertise is focused on building thermal environments and energy efficient design. And he has led various research projects on sustainable buildings, urban heat islands, mitigations, and has published widely in international journals. And Professor Suryamanto has also received national recognitions, including the Satya Lencana Karya Satya Award from the President of Indonesia. So please welcome for the first presenters, Professor Suryamanto. Thank you.
Distinguished Mr. Fahri Hamzah, Vice Minister of Housing and Settlement of Indonesia, Professor Sian Aziz from University of Southport, United Kingdom, Professor Alfi from the University of Florida, United States of America, Dr. Robi Sutanto from Labra University, United Kingdom, Professor Gusti Ayu Madiswartika from Udayana University, Bapak Rektor Udayana University, Professor Ketut Sudarsana. Ladies and gentlemen, everybody here, good morning. I'm truly honored to be here with you today. This morning, I would like to talk about sustainable settlement models, especially about how we can harmonize energy and environmental factors in our built environment. Next slide. Can you change to next slide? Okay. No, before this. Yes, after this, this is illustration. The man here is us. With in the left side, we support energy crisis problem, and the left side is environmental side. And this condition today, this environmental degradation is always happens every time. So in this illustration, we want to say that the environmental quality is worse and worse every time. So we need more energy to make to fix the environmental problem. For pollutant, we need energy for purification. For cooling, we need for energy for cooling. So every times we use the energy, we release more waste, more pollutant, and more waste heat to the our environment. Okay, next, please. This is our situation. It is our responsibility to make two side energy crisis and environmental degradation make balance to the pivot effect from energy crisis and environmental degradation. Next. How we have been adapting. It is the story about our adaptation process. In the first step, we had traditional wooden houses, naturally ventilated and well insulated by wood. Later, we shift to brick houses, hoping for better comfort indoors. But in this change, we had side effect. Brick production release carbon dioxide, and brick wall store heat during the day and release it back to our environment, making both indoor and outdoor hotter. It is the story of our adaptation process. As city grows, we build high-rise building with glass facade. This consumes a huge amount of energy for cooling and make the urban heat island even worse. Even modern solution like low E-glass, every building use low E-glass have to reduce indoor cooling risk, but they can still rise outdoor temperature. So even every adaptation seems fix one problem while creating another problem. That is I call a pivot effect, and often leads to toward to unsustainable condition. I illustrated like a one-way ticket, degradation of environment. Okay, next please. How about the role of building technology? Our responsibility to create the building technology. How the role of the building technology? As we know, the problem is not new. As early as 1820, Luke Howard already observed that cities are warmer than rural area. Why? Because the heavyweight material like brick, concrete, asphalt, they absorb a lot of heat, and then release it back into the city, rising air temperature and even contributing to extreme weather. As the figure here in the left side, this photograph showed that the roof tile, the brick, or the asphalt release heat energy to the environment. So this heavyweight material make our surrounding environment hotter. This phenomenon contributes to an increased demand of air conditioning energy in building. Okay, please, next. This is our survey. In Bandung, I calculate how the volume of heavyweight material, concrete, brick wall, glass facade, asphalt. I'm surprised that the volume of heavyweight material is very high. In this photograph from Landsat satellite showed that the heavyweight material like pavement, asphalt pavement, buildings show the red and yellow color. It means that this material release heat energy to the environment. So this phenomenon we know as surface urban heat island or SUHI. So this is the fact, the situation that the heavyweight material makes problems into our environment. Next, please. Another issue is our roof. This is critical. Many have poor insulation, letting in a lot of heat into our environment, to our room. This figure shows that the roof acts like a thin layer, which heat can easily enter and escape. By adding insulation, we can reduce this heat transfer to indoor. Next. This is our study also. We compare brick wall and sandwich wall. Sandwich wall is a wall with insulation inside the wall. We compare the performance, how the heat can transfer through this wall system, the block wall system and the sandwich wall system. In this study, we compare two types system. The brick wall tends to absorb heat energy from solar radiation, allowing more heat to pass into the interior. In contrast, the sandwich wall acts as a thermal barrier that block and slow down heat transfer. As the result, the brick wall can make the indoor space warmer, while the sandwich wall help keep the indoor cooler, although it may cause outdoor temperature more higher, slightly high temperature. So both system, heavyweight material or insulated wall, can negatively affect the thermal environment. It is not the solution also. Next, please. We want to look the other technology, please. Next. Thank you. Yeah. Berikutnya, slide berikutnya. Oke. Even double skin facade. It is the double skin facade. We familiar with double skin facade, often used as retrofitting program. This technology also affect our environmental negatively, tend to create hot surface layers on the outer surface of the building. Please, next, please. Reflective coating. It is very popular, very cheap, and I think it works better than the technology before. But this reflective technology works well when they get direct sunlight. If no direct sunlight, the performance not as good as if when they get the direct sunlight. So next, please. This is the conclusion, yeah. The conclusion is quite clear. Our current building technology are not yet sustainable. We are stuck with vicious cycle where every adaptation increase energy demand or degraded environmental quality. Next, please. So we have to rethinking our strategy. The need for sustainability means equilibrium. We need equilibrium. Next. For me, for us today, sustainability means equilibrium. Let's move to the second part of this discussion. How can we rethink our strategy? Next. Technology development often follows economic driver. Most of our technology, vehicle, buildings, even electronics, release heat and emit carbon dioxide, CO2. From an environmental ethics perspective, we need complementary technology. I have two arrows, the red arrows and the green arrows. The red arrows is our conventional technology. They emit the heat and carbon dioxide. We need the green arrows, the green technology. Ones that harvest waste heat, capture carbon dioxide, instead of produce more carbon dioxide and more waste heat. So we need technology. We must put our money to investation. We invest to this green arrow. So we investment on the green technology can help to maintain our environmental green. Next, please. Okay, we need to reconsider our current strategy. Now, let us move to on the third part of this discussion. Next. Here, because the building technology moves slowly, we want to learn from vehicle. We will take a closer look to electric vehicle or EVs, an excellent example of efficient and forward-looking innovation. Next. We compare. In the left side, EVs technology, and the right side is house technology. EVs consider wind load to reduce drag. Similarly, our buildings should consider cooling load. EVs reduce weight to improve performance. Our buildings should use lightweight material to minimize thermal mass. EVs recover energy during braking. Our building can recover heat energy from air conditioning and hot water system. Just as battery recycling is crucial for EVs, recycling building material should become standard practice. And of course, integrating renewable energy into building, that is no longer optional. It is very essential. This is the comparison we learned from the EVs technology. Next, please. We reached the fourth part, moving towards sustainability. Now, let's talk about our path forward. Next. According to SDG 13, climate action, the climate action SDG tell us we still need to balance energy demand and environmental quality. The message is clear. We must reduce fossil fuel consumption and turn to green energy. This illustration, the right is the action and the left side is the strategy. We have to make balance energy and environment. So the action is the must. We have to reduce fossil fuel. Next. One of the most promising options is solar power. For example, concentrated solar power, CSP, collect heat from a large area, store in molten salt, and use to generate electricity. This is from Nevada's new solar farm that can generate power 24 hours per day, 7 days for 7 days with molten salt. It's very interesting. Next. This is the diagram show how the solar concentrated solar power can generate the green energy. We need the green energy from our solar. Indonesia is located in equator, so we rich with energy. We rich with solar power. Next. From this discussion, we can begin to outline a new sustainable strategy for our environment. For building technology, there are 3 promising research agenda for the near future. In the left, right side, the action for the energy strategy. The first is energy harvesting. The second promising research agenda is energy conversion, and the third is energy storage. These 3 research agenda is very, very important for near future. We need this plan for sustainability of environment. Meanwhile, for environmental goals, there are also 3 key action agenda that must be pursued. The first is reducing waste heat from building for our city, for our district. The second is replacing heavyweight material with lighter and more efficient alternative or another alternative. The third is applying heat recovery system. Heat recovery system is new here, but it's very important. We need recovery system for capture the waste heat. Together, this strategy represents an integrated pathway toward a more energy efficient and sustainable built environment. So next, please. It is my imagination. I imagine a future where settlement can act like a solar farm, capturing energy while staying cool and livable. Make it this figure. I'm help with AI. Next. This is our agenda, transforming our built environment. So what's next? Our first agenda is to mitigate the thermal effect of brick wall system. The first line, the red diagram, and the second is develop new building system that can harvest and reuse the energy. It's our agenda, transformation agenda, to reach our sustainable settlement. Next. This is the illustration. The left side, conventional strategy, and the right side, new strategy. In conventional design, we let building absorb and reflect the solar radiation. In sustainable design, the right side, we aim to convert the energy into something useful. Instead of just removing warm air, we recover and reuse the heat. This is the conventional practice. We release heat from indoor to outdoor, and the new strategy, we have to recover the waste energy. Next. Technology like solar water heater are already common in Indonesia. It's a small solar water heater in our room, and we get warm water. Next. So we can take this further, we can take that further with solar thermal facade. I call it solar thermal facade, not like solar water heater, small part. The whole envelope perform like solar water heater. They absorb the waste heat from outdoor and collect the thermal, collect the waste energy, the waste heat, and reuse the energy. Next, please. This is the diagram how the solar thermal facade works. Yeah. For heating, for another purpose. Next, please. this is a model, a truly sustainable building. We put energy side and environment side into one house. No pivot effect, no trade-off. So they work together. In energy side, we collect the energy from our sun, our solar, and generate green energy. And the right side, the environmental side, we absorb the waste heat from the environment and also from our the solar, and we use the heat for another purposes. No more trade-off, no more pivot effect. It is a harmony between energy and the environment. Thank you very much for your kind attention. Have a wonderful day. Thank you again. I give back to Pak Doni.
Thank you very much, Pak Suryamanto. So I think it is a very good idea that we can develop the house and alongside with the energy producing the energy. It is not just about the how to make energy efficient use in the housings, but how to produce the energy itself in the house. So I think it is the idea. It is about the future. So we can have a collaboration for this idea. So maybe for the audience, I think it is very nice discussions for the questions and answers in the end of the session. So I would like to invite the second presenters in the sessions. Professor Zizan Aziz. And I would like to write your city first. Professor Zizan Aziz is a professor of Constructions Management and Engineering at the University of Salford, UK. His research focused on digital constructions, building information modeling, and sustainable built environments. And he has led and collaborated on various international projects that related to the smart constructions and innovations in the built environments. And Professor Aziz has published extensively in high impact journals and has been actively engaged in advancing digital transformations within the constructions industry. And the titles of his presentation is about the digital disruptions and modern methods of construction. So, Professor Aziz, time is yours.
Thank you very much.
About 20 minutes. Thank you.
Thank you very much for the introduction. Honorable Vice Minister, the Rector, Faculty of Udayana University and Faculty of ITB, very warm welcome. And first of all, I would like to start by acknowledging the great work done by ITB faculty in facilitating this workshop. So the focus of my presentation today is how to transition from a traditional construction to a modern methods of construction. This is consistent with one research project which we have, ongoing project with ITB. Next. So this project is funded by a British Council, and we have Dr. Devi as a from ITB as one of our co-PI, but we have got other faculty from Malaysia, Vietnam, and China. So the idea is to compare the best practices in advanced construction manufacturing and leveraging BIM, so that we could learn from case studies from UK and other countries as well. Next. So in terms of this specific project, the focus is on how we can improve from the traditional on-site construction, where we tend to do bulk of our work on a construction site, to construction which is done primarily in a factory, or taking a more manufacturing-led approaches, leveraging digital innovation, including intelligent system design. So as part of this project, we have done some training. We are focusing on curricular development, so we could upskill the workers, because part of this is not merely technology, but also some shift in our way of thinking, moving away from thinking of construction as a unique product to take more manufacturing-led approaches. Next. So in my presentation, I will talk about the need for why we need to take more industrialized approaches, why we need to learn from manufacturing sector, and the approach we have taken, and some of the building blocks of this manufacturing-led approach, like design for manufacturing assembly, developing the platforms, and BIM-enabled digital backbone, and what is required. So we had a very good discussion yesterday, and some of the key findings from the session. Next. So first of all, I would like to clarify some terminologies. So in the UK, we tend to use this term called modern methods of construction, and government is encouraging a lot of the public sector projects to use modern methods of construction. So we use a terminology called PMV, or pre-manufactured value. So for instance, if you are developing a hospital or a school, there will be an expectation that you make use of maybe 15%, 20% of the pre-manufactured value. So this includes 3D primary structure systems, 3D units which are developed in a factory. MMC also include 2D primary structural systems such as flat panels for floor, walls, and roof structures, non-systemized primary structures, additive manufacturing. So everything which is part of the traditional off-site and near-site pre-manufacturing world. But also it includes some site-based process improvements such as traditional building product-led site labor reduction strategies, and some innovative strategies such as drone or so. So the projects are encouraged to make use of these modern methods. Now we see different terminologies used. Often in this part of the world, we use a term called industrial building systems or off-site construction. More or less the concepts are parallel to each other. Next. So in this concept of modern methods of construction, it builds on a traditional off-site factory production, which has included things such as design for manufacturing and assembly, also DFMA and disassembly and flying factories, but merge it with some process improvement methodologies, including additive manufacturing, traditional building product-led efficiency improvements, and site process-led efficiency improvements. So there is a lot of technology involved in this whole motion. Next. But the key question is not of technology, but understanding why we need to focus on more industrialized approaches. So there is some data from the UK, and we had a discussion, similar sort of a problem. In the UK, we have a shortage of 1.5 million houses, and this is growing by 300,000 houses every year. So using a traditional approach, we cannot meet the demands of growing population. So we have to take more a manufacturing-led approach. Construction also is a very risky industry. There are a lot of injuries and deaths taking place due to construction work. We have a problem of skills shortage. A lot of the construction workers are getting old, and training the new workers is getting difficult. So highlighting the need for taking some of the construction work into a factory. Also the youngsters, they are not being attracted to construction. So how we change the image of the industry, there's a concept of this 5 Ds. Construction is dull and dirty and dangerous and demanding and always delayed. And youngsters are going into professions such as software engineering and finance. How we can change that image of construction so that we could attract, and also this environmental impact, as was highlighted in the previous presentation, how we could reduce the carbon emissions resulting. So it's very important to understand what are the key drivers for industrial construction. Next. So this is some data from the UK government, and the UK government is not happy with the performance of construction sector, and they have written a lot of reports. By the way, government is the biggest client of construction sector. They sponsor about 40–50% of the construction activity. So here it's a reason of project delays in the public sector, and it includes things such as poor productivity, operational stoppages, labor shortage, lack of material. So on-site delivery faces a lot of issues. As a result, so next slide. The government is saying they are not getting a good value for money. So there are a lot of reports which are coming from the government. So there is, for instance, one report from the government, Rethinking Construction, which was launched about 25 years ago. And they said that construction need to change its mindset and take more manufacturing-led approaches. So here on the graph, you can see construction industry, which is shown in the line at the bottom compared with the manufacturing. Manufacturing productivity is increasing steadily year-on-year basis, almost 3-4% productivity growth, whereas construction productivity has remained stagnant, not improving. And a lot of challenges the industry faces, such as low profit margins, low productivity, projects getting delayed, projects not being delivered on time. So we need a certainty in infrastructure delivery. Next. So this is the data from the government. And in this, basically, they are saying that we get only 50% of the value. Only 51% of our budget, for instance, if the government wants a hospital, only 51% is spent on the hospital. Rest of it is all the overheads, like client risk, the supply chain overheads, site overheads, client fees consist. So for instance, if you take an analogy, if you're buying a car, you will just pay for the car. You would not like to pay a top fees for the showroom and all those overheads. So the government is saying we are not getting a good value for money from the construction sector, basically. Next. So first of all, we need to understand the difference between the construction, traditional construction, which is primarily on-site, and the industrial construction. And the difference is not so much on the technology, but it's also in the mindset. So in the traditional one-off project-based construction mindset, we think every school which we are constructing, every hospital, every building, it's a one-off project. So on the left, you can see this traditional mindset, which says construction industry produces a one-off bespoke products. Every new building is a unique prototype. We deal with temporary organizations which are set up to undertake projects, and the teams are dismantled upon completion. So we learn a lot of things, but once the teams are dismantled, we lose all that knowledge. Cross-project learning is very hard because knowledge is typically lost. The industry is based on adversarial practices that restricts the passing of information freely. So a lot of conflict. So there is a view that it's difficult to apply the manufacturing approach. But on the right-hand side, you can see the reason, the counter arguments. So firstly, it says it demands a shift from a project-based to a product-based repeatable processes. The focus is on standardization and repeatability. The focus is on mass customization, automation, and process improvements using standardized components such as design for manufacturing and assembly. It requires stable industry-grade supply chains and long-term strategic partnerships which are built on trust. This enables just-in-time delivery and managed logistics. So there is a bit of a shift in the mindset which is required. So there is a famous quotation by Alvin Toffler that the illiterate of the 21st century are not those who cannot read or write. It's those who cannot learn, unlearn, and relearn. So a lot of us have been trained in this left mindset where we think of construction as a unique asset. So we may have to do a bit of unlearning to get ourselves ready for more manufacturing-led approaches. Yeah, next. So again, continuation of the arguments of the one-off construction mindset and counter arguments of why we need to take a more manufacturing-led approaches. Next. So how it is going to change the shape of the industry. Here you can see this famous graph by Patrick McLeamy, which is a level of influence diagram. So here you can see basically the line in the blue, the number one, it's basically saying ability to impact the cost, and line red is cost of design changes. So when the project is at a concept design stage, your ability to impact the cost and the cost of design changes are maximal. So the idea is you need to do bulk of design thinking upfront. But what's happening in a traditional design process, which is number 3, a lot of our thinking and analysis is done quite later in the life cycle stages. So the shift that we are seeing through this transfer to more industrialized approaches using BIM and industrial construction is moving this peak, which is quite late in the life cycle, to slightly more left, so that we could do a lot of design thinking upfront. Next. So what it involves is basically shifting the construction sector, which has delivered its projects more like playing a relay race. So the way we deliver our hospitals or schools, basically the architects come up with the initial concept drawings and detailed drawings, and then the baton gets passed to the structural engineers, and then on to mechanical engineers and plumbing engineers, and so on and so forth. So this is more like relay race style working. This has to shift to a more collaborative working, like playing a football or playing rugby, where there's a great deal of teamwork. So that would require fundamental shift in the way the information is exchanged and how teams work together to take a more industrialized approach. Next. So this fragmentation in the construction is also reflected in the way IT systems are developed. They are very fragmented. It's more like islands of automation. There are different software tools to support engineering design and architectural design. They do not speak to each other. We have built some patchy roads and some patchy exchange pathways, but they do not work very smoothly. So we need a more integrated approach looking forward. Next. So in our project, we have focused on the need for upskilling workers in design for manufacturing and assembly. So this design approach is optimizing manufacturing needs and assembly efficiency, while also considering the entire life cycle of the building, including the end of life. So these three key components include standardization, repeatability, and automation, which are central to the design for manufacturing and assembly approach. Aim is to reduce the number of components, leading to faster assembly times and lower costs, enable faster construction through prefabrication and greater sustainability by reducing waste in manufacture. And DFMA protocols are combined with BIM for the design and production of three-dimensional models and assembly drawings. Next. So in the UK, we see the professional bodies such as REBA have provided overlay of work. So the construction work in the UK is divided in 7 different phases, starting from REBA stage 1, which is strategic definition, to REBA stage 6, which is handover of a project, and then in use. So how we can use the manufacturing-led approach in each of different phases, and what sort of considerations we need to have at each stage. Next. So we, in terms of industrialization, we are seeing the industry moving through different levels of maturity, starting from traditional construction to use of prefab, which we have seen for past many decades, to the switch to mass production, and now going through the next wave of maturity, where we are moving from mass production to a more platform-based approach, very similar to the manufacturing sector, how cars are assembled. So they make use of platforms. Similarly, use of platforms for building our buildings. Next. So this is the vision of how the current manufacturing is taking place. So in each project is still currently being designed from scratch. The architects come up with the initial drawings, and then we look into where manufacturing could fit into this. So where we can involve different suppliers. So this is the current approach, which a lot of projects are making use of industrial components within their projects. Next. So in the current approach of industrial construction, which is quite fragmented, the client comes up with the employer information requirements. So for instance, if it's a hospital, what are the key requirements of a hospital? This is translated into a project requirements, and then client chooses a suitable modern methods of construction system, which could include volumetric systems or 2D systems based on this. So we are trying to mix and match the traditional on-site construction with an industrial construction. Next. So in the next level of maturity, which we are seeing the industry is currently going through, we are moving towards product platforms. So based on the employer information requirements, we identify which product platform would be suitable. So there's different platforms for hospital buildings, health buildings, and then based on this, we develop a project definitions, and then leading to industrial suppliers providing the components. So if it's a hotel, could include volumetric systems or 2D structured systems. So taking a more platform-based approach, which allows for more standardization and repeatability. Next. So this is the vision of the future as presented in McKinsey's report, The Next Normal in Construction, where we will leverage more platform-based approaches. So rather than starting every new project from blank sheet of paper, we would make use of existing platforms to customize our design so that we can make use of industrial approaches later in the life cycle. Next. So in a platform-based approach, it seeks to establish commonality in parts, processes, and relationship. In the UK, the government has launched the product platform rulebook, which basically sets the 5 critical areas which have to be monitored. Firstly, the product platform development. It requires strategic decisions for planning and designing repeatable components. Clarity is needed on what constitutes the core. The digitally designed components includes centralized BIM library of different industrial components. The platform leadership and ownership identifies who will lead and own the catalog of the industrial products. The platform governance is a rule book for accountability, and then business model innovation. So the overall objective is to enhance the asset performance against international benchmarks, delivering enhanced quality, low carbon footprint, and increased whole life value. Next. So this is how the future workplace would look like, few scenarios, how construction industry is changing. Firstly, client comes up with a 3D tender model, which is launched to a common data environment. So that's a single source of truth. The design is moving away from a bespoke design to a more generative engineering. So AI produces different list of options, and we apply generative engineering principles. So for instance, in this example, the systems generate 3 different options for a bridge, and the engineering team suits the most appropriate to the site context. In terms of analysis, we are moving towards automated system analysis, and the pricing is drawn from the using central database analysis of historical tender performance. Next. In terms of the construction phase, we are seeing increasing use of technologies such as augmented reality for briefing and analysis. We are seeing the BIM as a single source of truth, which is continuously enriched by different layers of information such as 4D, 5D, 6D, including information about the carbon, and 7D, which is operations and maintenance data. And in terms of the on-site delivery, we are seeing increasing use of automation and robotics to facilitate the on-site assembly of the industrial delivered components. Next. And at the project completion stage, we not only give the printed drawings, but we provide a digital twin model so that the asset delivers as it was promised. The information is handed over to the client digitally. So a real-time closeout of the project, AI-generated reports, and digital twins are utilized for optimized operations and preventative plant maintenance during the asset life cycle. Next. So within our project, we have focused on enhancing the skills of our graduates in this area. So yesterday we had a workshop where we looked into different areas where we need to enhance the skills. Firstly, identifying the fundamentals of industrial construction, the digital skills like BIM, DFMA, AI. So their students are clear about the different tools and techniques, the health and safety, how it is managed for on-site operations, and how it will be managed in factory procurement contracts, factory operations. So some outline curricula to ensure that students have the requisite skills to operate in an industrial construction environment. Next. So the vision is to make the construction faster, make construction safer, cleaner, and cheaper through industrial construction. We need a clear leadership and roadmap to drive adoption. The transition demands a fundamental shift in the mindset, procurement, and skills so that we could better leverage digital platforms and manufacturing principles. We must collaborate across government, industry, and academia to establish necessary policy mandates, standards, and skill sets to achieve a sustainable and productive built environment. And core barriers are often not technology, but these are more cultural, financial, and relational, which needs to be addressed. We must share learning and look to more sophisticated industries for knowledge transfer and develop long-term institutional partnerships between academia and industry. Next. So the government has a big role in this. So as the biggest client in the construction, what we see in the UK and other countries, they have focused on demand aggregation. So government must leverage the procurement route to create a long-term visible pipeline of demand, because to switch to industrial construction, there's a huge investments involved in setup of the factory. So there has to be certainty in the demand. There is a need for shift from procurement for cost to value. So this traditional model of focusing on the lowest bidding contractor, that has to shift to more value-based approaches, and need for more regulatory reforms such as standardized building codes and components to enable economies of scale. Next. We also need to focus on skills and training investments, fund skills academies and apprenticeship programs to ensure the youngsters are upskilled with the skills required for industrial construction, some fiscal intervention to encourage long-term partnership and pipeline visibility to enable supply chain investments. So these are some of the conclusions drawn from our discussions in the workshop yesterday. So that concludes my presentation. Thank you very much for your time.
Thank you very much, Professor Siva. And from Professor Siva, we can have some conclusion actually, that the future's already here, already comes, and how we build in the future is different. And from now, it is about how we use the many equipments that already exist right now. It's like VR, ER, AI, machine learning, digital procurements, digital logistics, and how we have to collaborate across multidisciplines. That's very important. And we need to reform the standardized of building codes and the policy in the futures in Indonesia. Okay, thank you very much, Professor Siva. And the third presenters, I would like to come to this. Eva, can you hear me?
Yes. Can you hear me okay?
But I cannot hear your voice. Sorry.
Oh, the audio is
okay,
on.
okay. Right now it's already, yeah, it's
It's
good.
okay.
Yeah, before you make a presentation, I will read your CV first. Okay, Dr. Eva Olian is an associate professor at the Florida University. It used to be Pad University UK, moving to Florida University US right now, and specializing in net zero and regenerative design. She holds a PhD and Master of Philosophy in Architecture from the University of Cambridge, and has over 15 years of international research and teaching experience across the UK, Norway, and Southeast Asia. Her work focused on embodied carbons, net zero design, and data visualizations for sustainable architectures. Dr. Eva has served as national representative for several international energy agency programs and continue to lead global collaborations in advancing climate resilience and regenerative building designs. So Eva, time is yours for 20 minutes from now. Thank you.
Great. Thank you so much, Pak Doni. Very nice to see you. I really wish that I was there in person, and I apologize for this, but thank you for accommodating me online. So, dear Vice Prime Minister, ladies and gentlemen, esteemed keynote speakers, I'm really very honored to be invited to give this keynote speech together with you. So just to double check, will I just say next and my presentation will come on, or should I share from my laptop?
Just say next.
Just next. Okay.
Okay.
Do you have the first slide then, please?
Yes. Yes, already, Eva.
Oh, I can't see it.
First, you cannot see it?
No. Is it possible for me to share or no?
Oh, yes.
Yeah, because I can't see the presentation.
Slides? Oh, yeah. We can see your presentations, but I don't think so that you cannot see your presentations?
No, I can only see myself.
Oh,
sorry.
So you can share by yourself?
Yeah. Okay, let's see.
Okay, so yeah, share it.
Sure. Yep. Oops. Gosh, sorry. Hopefully, if I put it on full screen, can you see it now?
Yeah.
Yes.
So, please.
Okay. Okay, so thank you. So as you all know, a climate emergency has been declared, and the key question is, what action are we going to take? As we're all familiar all around the world, we're experiencing more and more extreme weather effects. And these are becoming they're strengthening, and they're happening with a lot more frequency. So the key point is, the choices and actions that we implement in this decade will have impacts now and for thousands of years. So despite the fact that, as you can see in the top line, we have missed some opportunities already for higher climate resilient development. However, all is not lost. We still have, albeit a narrowing window of opportunity. If we act collectively and we take action now, we really do still have a chance to keep global warming below 1.5 degrees. So the key message is the future is now, and climate mitigation is not enough. So we have a huge wealth of, hundreds and thousands of years of experience between working with the environment, and we have a huge amount of knowledge on sustainability. And over the past 15 years, even in my own time, we have built up a huge amount of knowledge on climate mitigation pathways, net zero emission design. But what we're seeing is that particularly in the last 5 years, in light of the extreme weather effects that we're experiencing, we really need to be moving away from just this focus on reducing harm to more of a paradigm shift to repairing harm and developing more resilient, regenerative, and biodiverse solutions. So the key point is that we have all this experience on climate mitigation. We have a huge amount of experience on climate resilience, but we really need to bring these two areas together to develop more resilient, regenerative solutions. So to achieve this, we need research, industry, education, all to work together and really embed a more regenerative approach. To do this, we really need to enhance biodiversity integration of nature into the built environment. We need to be promoting and prioritizing sustainable and low carbon materials, particularly through reuse and recycling. We need to be really focusing on energy efficiency, waste and water management, prioritizing a circular economy, and most importantly is really a more place-based approach. So having more community engagement, co-designing in response to local risks. So you may ask yourself, well, where do we begin? It is very overwhelming. So what I'd like to present here in this part of my presentation is some lessons learned from our experience in Norway over the past 15 years. So I'd like to show and share with you some experiences on pathways to achieve net zero emission buildings and neighborhoods in smart cities. So you also may be asking, why zero emission buildings and neighborhoods? Well, the building and building construction sector are responsible for nearly 40% of total direct and indirect CO2 emissions. This also means the energy use and related emissions may double or potentially even triple by 2050. This is largely due to an increased access to adequate housing and facilities for people in developing countries, but also as a result of population growth, migration to cities, household changes, and increasing levels of wealth and lifestyle. So the bottom line is improving the energy performance of the building stock and developing zero-emission building and neighborhood concepts are really crucial to avoid an increase in energy use and greenhouse gas emissions. So how did, in Norway, the country signed up to be net zero by 2030. The Norwegian Research Council set up the 8 research centers, all focused on different pathways to achieve this common goal. And the main aim was, to increase innovation and value creation in participating public institutions and private businesses, as well as Norwegian society in general. So there were 2 phases to the research. The first phase was focused on zero-emission buildings, and the main objective was to develop competitive products and solutions for existing and new buildings that could penetrate the marketplace. So they shouldn't be so innovative or so costly that they couldn't be implemented in the marketplace. And they also needed to have net zero greenhouse gas emissions across their whole life cycle. The second phase of the research was over the next 7 years, and that was really focused on shifting from building to neighborhood scale. And the reason was to speed up decarbonization of the building stock, use more renewable energy sources, and most importantly, to create positive energy synergies between the building stock. So a key factor, I guess, a big lesson learned was, I guess, the funding was large scale, but the duration for both was 7 years each time. So this really allowed us to develop the concepts, but actually build the buildings. And another really important aspect to both approaches was the involvement of all people around the table from the very beginning. So it was very multidisciplinary. So it wasn't just, academics, it involved industry partners, it involved local municipalities. So everybody sat around the table from the very beginning. So if we just look at whether it's ZEB or like a building or a neighborhood scale, we had clear objectives, which I've just spoken about. We were working across scale. So some researchers were working, at developing nanoscale materials. Then we had to look at how do we scale up into building components. Then we had to, test these out in living labs. Pilot projects, and then actually build these buildings. So there was, how do you say, an iterative process through the development of the living labs, because the living labs acted like a bridge between research and practice and really enabled us to see, did our theory work in practice? If not, we were able to go back to the drawing board before actually implementing the built projects. So just to clarify, what do we mean by a zero emission building and how is that different to a zero energy building? Well, as you can see in this graph on the left, the red represents the energy used in a building. And essentially, when you're balancing that with renewables, then we have our lowest ambition level. So we've got a zero energy building or a zero emission building for operation only. So that was our lowest ambition level. However, what we see then is that we need to include, with a zero emission building, we're taking into account all the embodied emissions for all the materials in the skin of the building, the technology, the infrastructure. So we need to account for all the embodied carbon for the materials. So that is shown in a very simplistic way in the blue part of the graph. But essentially what you can see in a nutshell is on the left side, you have a demand of emissions from operation and embodied emissions for material. And what you're trying to do is to balance that with renewables on the green side. However, it does not mean that, I can have, a very high demand side and it's fine. I'm just going to balance it with renewable emissions and then I've got a net zero emission building. No, what we've got to do is still really work hard through our design to have highly energy efficient buildings. So the red part becomes really low and we're conscious that burden shifts then, achieving that high energy efficiency shifts the burden to embodied carbon. So it just shows you that you need to really include the embodied carbon and not just focus on a zero energy approach. Otherwise, you're missing such a huge part of the picture. I don't really have time to go into the details of the ambition levels, but just to show that there are many levels involved. But I wanted to move more onto the fact that, a key learning for us with the living labs and the pilot projects was, like I said, to take our theory and really implement that on the ground and through a multidisciplinary collaboration, as you can see with our partners below. And this really, the industry really relished this, and they've really found it such a useful way to actually understand how to deliver a zero emission building on the ground. So the living labs for us really acted as innovation hubs for co-creation between all these different disciplines. And also, we involved citizens, we involved students. So, it was a wonderful environment to be in. The living labs also allowed us an opportunity to verify, document, and optimize the theory versus, the real life performance. And finally, the living labs acted as lighthouse projects to learn, inspire, and disseminate the knowledge. So we have, and all of this is available on the ZEB and Zen websites. So we've built all these building scale, and they showcase different pathways for different building typologies, different scales of buildings, and they also showcase strategies for existing and new buildings. So when we move to the Zen scale, obviously, when we're talking about a neighborhood, this is essentially a group of interconnected buildings with associated infrastructure, and they're located within a confined geographical area. So the precise definition and all the KPIs are included in this report on the right side. But in a nutshell, you can see when we shift from building to neighborhood scale, then we're suddenly, increasing and having to deal with so many more KPIs, key performance indicators. So the complexity increases, as well as the need to shift across scale. So Professor Aziz's work is spot on. We really need to use digital methods, to really help us transition across and deal with the complexity. So at the Zen pilot, for the Zen scale, we have a number of these pilot projects which are currently under construction, which showcase the neighborhood scale solutions. So that's all well and good. So we have all of this knowledge on climate mitigation, but it's very localized in the global north. So when I was actually doing a research sabbatical in the US at Berkeley, this is probably 6 years ago, it became very clear to me there was a huge amount of knowledge on climate resilience. But it didn't mean that a climate resilience solution, which could withstand hurricanes or forest fires, was considering a climate mitigation approach, and vice versa. Our ZEB or Zen buildings, you put those in Florida or California, and they would not withstand these extreme weather effects. So that's where the seeds for our current project came about. It was really identifying the need that we need to take both climate mitigation and climate adaptation to a more resilient and combined approach. And we really need to work with vulnerable communities in different parts of the world that are really at the forefront of climate change. So it was really about how do we use living labs as a bridge to share our knowledge from the global north to global south. So after a lot of effort, we had this dream team, but we couldn't find any money. And then it was my PhD student, Daniel Satola, who found this Canadian call that allowed us to have this international project with our esteemed colleagues at ITB. And the title of the project is Participatory Collaborative Research to Enhance Climate Change Adaptation and Mitigation in Vulnerable Communities in Asia and North and South America. So we have 3 global living labs. We have one in Indonesia, Java, we have one in Medellin in Colombia, and we have one in Texas in the USA. So how does it work? The research takes 3 different steps. So the first step, which is where we are right now, it's about identifying climate change related needs assessment. So identifying the environmental risks both now and at different points in the future, and really understanding the local community needs so that we can identify the valuable vernacular knowledge that exists in the place. And the second step will be based on the findings of one. So bringing together the international teams and the local knowledge and our local partners, we're going to co-design solutions through participative activities to co-design regenerative solutions, taking on board the community's needs and knowledge. And the third step will be to co-implement the solutions. So, for example, in Colombia, they're going to actually build the living lab. In Indonesia, we're going to create a blueprint of different solutions, which the community can then decide to take further and build. So the resulting strategy will be replicable in other built areas around the world. So we're really hoping that the solutions that we're going to be developing here can help other communities elsewhere. So we're a big team. We have 9 international partners, and we have 3 focused areas: construction, engineering and materials, social science, and architecture and regenerative design. We've got 3 living labs, as I've just said. ITB is leading the Indonesian living lab, and we work with local industry partners. So we have 3 main phases to this. So I've largely spoken about it. Basically, we're at the point now where we're identifying environmental risks, and then we have in parallel social spatial analysis of current and future needs and resilience scenarios. And then we're going to start co-designing these regenerative solutions, and then we're going to embed this knowledge and co-implement these final solutions and really build long-term capacity building. So I have no idea how I'm doing time-wise, but essentially we have our 3 living labs. The common ground is we have climate change related needs assessment, step 2, co-design of solutions, and 3rd step, co-implementation of the solutions. So I'm going to walk you through the 3 living labs, and I'm hoping that Pak Donny will just give me an indication of my time, but we are quite a large team working with the Indonesian. So we have ITB, University of Bath, and NTNU in Norway. So where are we? We're working in the north coast of Java in Indramayu, and particularly in the Kandangor area. So in the Indramayu Living Lab, the focus will be on, we started off looking at fishing and farming communities, but now we've narrowed that down to fishing coastal communities, and we'll be focused on water and food security. The hazard we're dealing with is flooding and rainfall variability. And the community, as I said, we've now focused on coastal fishing communities, and we're going to be dealing with water and energy management and ecological connectivity. So we are focusing now on 2 particular areas, Eretan Wetan and Eretan Kulon. Sorry about my pronunciation, but these areas are particularly very vulnerable. We're receiving reports of twice daily flooding in some areas on a high tide, and the highway, which is linking Jakarta with the east of Java, is running very close to the coastline. So there's a big vulnerability there also in food supply. So what we're seeing is the initial modeling results are showing recurring flooding and sea level rise, particularly in these low-lying coastal communities. And this coastal and fluvial flooding has greatly accelerated in the past 5 years, as you can see in the graph on the right. It's also compounded with sea level rise, land subsidence, and shoreline dynamics. So there's multiple hazards for this area. And you can see the flooding that happens within the communities, and you can see the measures the local communities are making by themselves. So the findings, and this is very, very preliminary, the areas around Eretan are probably now permanently flooded due to a breach from the ocean. And this is due to climate change causes, but in addition to other challenging environments. And some parts of Eretan Wetan are now seeing this twice daily flooding and some waves occurring in the town. Flooded areas are increasing, and any construction north of the highway appears very unsustainable. So moving on quickly now to United States, this is the Texas Living Lab, which is led by Manish Dixit at Texas A&M, and it's in the Jefferson County. It's an area that's really very vulnerable due to hurricanes and tidal surge. So in this living lab, the focus is on the built environment and surrounding. The hazard is hurricane flooding and extreme heat. The community are underserved and marginalized communities, and it's about developing carbon neutral and climate resilient housing. So this is just showing you the area, and essentially the main hazards that we're observing so far are recurring hurricanes and flooding, 56 storm impacts happening, and hurricanes striking every 9 years. Extreme heat by 2050, Port Arthur could experience about 124 danger days, and there's high socioeconomic vulnerability in the area. And finally, the Columbia Living Lab is in Medellin, and it's led by our colleague Harlem Aguidello, sorry, and that's ITM in Medellin. So this is the La Iguana micro basin in the city of Medellin. And in this living lab, their focus is on housing and watershed protection. The hazard is flooding and landslides. The communities are displaced and informal settlements. And the approach is about resilient and modular construction and buffer strips. So these are just some images showing the socio-environmental challenges. So to wrap this up, what are our next steps? Well, we're very early in the project, but our main objectives will be to strengthen participatory governance through alliances between institutions, academia, and local communities. Secondly, we want to promote regenerative solutions in different vulnerable communities, for example, the urban microbasin or rural coastal communities, by integrating education, culture, and sustainable practices. We want to enhance community resilience by building local and long-term capacity so that we can foster solidarity and circular economy. So how are we doing this? We're very conscious, if I'm just taking the example of our Indonesia Living Lab, we really want to build that long-term capacity building. So in our recruitment efforts, we were focused very much on finding, ideal and talented PhD researchers. So this is our esteemed PhD researcher, Alam, who's supervised by Donny and Bodewi and myself, and his research is on regenerative solution model to leverage local potential through a co-design approach to enhance climate resilience in coastal settlements. Then we have Koi Noor Siyahid, who's focused more on strengthening socio-cultural aspects in socio-ecological resilience as climate change adaptation strategies in coastal areas. And then we have two postdocs as well. So we have Dr. Bintang Noor Prabowo, who's a postdoc at NTNU in Norway, and his area of specialization is in urban scale and community-based facility management. He has extensive expertise in urban heritage areas. And Dr. Catherine Arel at the University of Bath, she's got extensive experience in understanding and mapping hazards and risks, particularly in Nepal. And her research is really looking at how we can move beyond traditional representation of hazards. So then we're not at this point yet, but obviously we want to really draw upon the local knowledge at ITB and the expertise. During our recent visit, we were able to visit and meet with Bapak Permana, who showed us this wonderful technique of using waste wood materials and forming them into modular components, which he could then build these, they're flat packed and then they can be built into these living pilots. And then we met Bapak Andi, I'm not even going to try and pronounce the surname, sorry, but he has esteemed expertise with bamboo detailing as evidence in our visit from Three Mountains. But also, we want to really think about how we can leverage the knowledge on local materials in innovative ways. So we're quite interested to work with other experts. Yes, I shall finish up. Yes. And this is my last slide. Beyond the project, we also have PhD researcher Omar Ahmed, who's working with waste agricultural materials, and we're looking at how to make these materials more durable, and form them into modular units. So that's it. Terima kasih. And here's our team. We're all over the world, and we're really excited to work together with you. Thank you.
Okay, thank you very much.
Thank you.
Unfortunately, you could not come to Bali again.
I'm very sad about that. Oh, very sad, but I'm hoping you will have me another time.
Yes, thank you. So From IFA, we can get some insight about the net zero energy for the neighborhoods. And decarbonizations in Indonesia, even not have the definitions of net zero energy in Indonesia. So we have to find what kind of net zero energy or NZEP in Indonesia, the standardizations and the definitions. And we already have 3 presenters that already connected actually. One is net zero energy for the neighborhood, regenerative architectures. Another one is about how to produce energy in the housing systems from Professor Surjamanto, and how to make some constructions for the future from Professor Ziva. So I just have 10 minutes from now. So I would like to invite 2 questions from the audience. And if you have questions, just raise your hands once and another once. And the second questions. Okay, from
My name is Johan from Viro. My question would be for Dr. Aziz. One of the things that you mentioned earlier regarding this trend from manufacturing on site to prefabricated building. Now, oftentimes one of the challenges that we've seen is a lot of times regulation is designed for manufacturing on site, especially building code inspection, things like that. Have you seen trend in many countries about updating a regulation where prefabricated building can be certified, like let's say, for example, vehicle. So inspection is not done per building rather than as a class of building, certification and then implementation. Is that something that you're seeing right now? Thank you.
Thank you. My name is Alam. I'm a PhD student from ITB. My question is for Professor Zizan Aziz. Your presentation is very interesting for me, particularly because it contains a message of shifting from traditional construction method into the more industry-led construction method, particularly the platform-based construction approach. If you perceive it as supply side housing provision scope. On the other hand, we also have a demand side housing provision scheme. My question is how to align this new construction strategy with the demand side, i.e. the co-design process, because the aspirations from the local community is also important to the success of this construction, maybe new approach in the general context, and also particularly in a low income and informal context. Do you have any idea of how to make it happen successfully in this informal context? Thank you.
Thank you, Professor Aziz. So there is 2 questions. It's about the updating systems in the whole country in the world. And the second question is about supply and demands for the informal sectors, not just for the highest living people.
So I think your question, first of all, relate to prefabrication and things. I think historically, prefabrication in the UK has not enjoyed a great deal of a reputation. It was associated with poor quality, and rather than helping this, so the industry has went through some level of maturity, and now on top of prefabrication, because a lot of the time, if the buildings were prefabricated, the banks would not be able to loan money against those buildings. So now the focus is on this notion of moving from beyond prefabrication to standardization, and now towards developing the platforms. So the idea of a platform is basically that you have standardized your building components, which would include your walls, your panels. So as a designer, it's an abstraction for you. So rather than you will be using the component libraries, and but those platforms will be thoroughly tested, and you will have a robust data backing them. And also financial institutions and the government putting its support, because we are talking about economics of scale. So, and those platforms will be very thoroughly tested. So moving away from ad hoc approaches which were very difficult to control, to more a platform which could be standardized, where we could bring more standardization and repeatability. So I think this is where we currently stand. Even in the UK, if it's a prefabricated building, it will be very difficult to secure a mortgage. Banks will not be funding it, and there will be a lot of issues with building quality. So I think from a UK perspective, we are seeing now this move towards developing the platforms, and these platforms are thoroughly tested, and then there is a demand aggregation based on those. Yeah. So I think the fundamentals of manufacturing includes things such as standardization, repeatability of the same thing, and leveraging the economics of scale. So I think we are still in the early stages. We are seeing a lot of construction firms who are in the manufacturing sector. They are currently struggling because of this, because there is not a great deal of demand. So if we see every new technology has an adoption curve, and it goes through certain levels of maturity before it gets to that level. So even in the Europe, across US, you will see a lot of companies have struggled because demand is currently not aggregated. And setting up a factory is not easy. You require a lot of investment upfront in the equipment. So we are talking about millions and millions of dollars to set up the company. So I think now the push is coming from the government to provide a robust demand, which would allow for investments within the manufacturing setup. But yesterday we had a very interesting presentations from Malaysia as well. So there are a lot of companies such as Gamuda Engineering. There was a case study presented, which are very vertically integrated. They wear different hats. So they are not only manufacturers, but they are also contractors in their buildings. So they have got a steady supply demand where they could apply manufacturing principles. So I think the answer is not so simple and straightforward. I think we are still in the early phases of this movement towards platform-based thinking. We have got certain good case studies, and companies are going through that process of maturity. So I think this is a case of watching the space, and things will evolve clearly over the next decade or so.
Yeah.
Okay, thank you very much. So we can discuss later in the break sessions. Unfortunately, we don't have any times because already the committee has already mentioned me that the times is up. And I think we have a big applause for the three presenters. Now, thank you very much, Professor Sunyamanto, Professor Aziz, and Eva. Thank you very much, Eva.
Thank you.
And please come again to Bali and to
Yes.
ITB. Thank you very much. And
Thank you.
yeah, thank you. Thank you very much.
Bye.
Before we continue, I would like to invite the Honorable Dean of SAPPK ITB, Dr. Alice Nurdini, to the stage. Please go to the stage to give a certificate and also some appreciation from one of our sponsor, Dexon, to three of our speakers today, which is Professor Suryamanto, Professor Sizan Aziz, and also Dr. Iva Haulian Wiberg, and our moderator for today, Dr. Doni Kurniawan. For the group and for the photo session, for the group photo session, for organizing committee members. Okay. Okay, thank you, Dr. Doni Kurniawan and all the distinguished speakers.
Ladies and gentlemen, before we continue, we will show a PPT slide from ACC Japan. And for all participants, please scan the QR code to fill out the questionnaire. Once again, for all participants, please scan the QR code to fill out the questionnaire. Ladies and gentlemen, we now move to our second sponsor presentation from Dexon. And this presentation will feature an interactive quiz with attractive prize. We invite the representative from Dexon, Ibu Gertrudis Haudra, to deliver the presentation.
Halo, selamat siang. Ya, tadi lumayan untuk diskusinya berat ya. Oh ya, maaf sebelumnya mungkin saya presentasi by bahasa Indonesia ya. Karena presentasi ini nanti nggak terlalu berat dan hanya berisi kuis-kuis gitu. Jadi saya nanti akan memaparkan beberapa slide. Nah, nanti ada pertanyaan dari saya dan dapat merchandise untuk yang menjawab pertanyaan tersebut. Oke? Ya. Next. Ya, mungkin sebagian sudah tahu untuk Dexon itu produknya di aksesoris pintu dan jendela ya. Tapi selain itu kita udah merambah ke bidang sanitary, terus ada juga smart living unit, smart door lock yang seperti Bapak Ibu ketahui mungkin ya. Terus ada juga aluminium composite panel, begitu. Oke, next. Ya, ini untuk journey Dexon ya. Kita berdiri di tahun 1994. Dan kita awalnya itu untuk aksesoris pintu dan jendela aluminium. Kemudian merambah ke aksesoris pintu dan jendela kayu. Kemudian di tahun 2008 kita membangun kantor cabang ya. Yang pertama itu di Jakarta Barat gitu. Jadi nanti kalau misalnya ada yang ke Jakarta Barat bisa juga buat appointment di sana karena kita ada showroom yang terbesar begitu. Oke, di 2019 kita membangun ulang tahun ke-25 ya. Jadi kita membangun untuk Dexon Knowledge Hall. Mungkin Bapak Ibu yang sudah pernah ke sana, ya itu tepatnya di Jakarta Barat. Dan kita juga merambah untuk produk ACP, begitu atau fasad bangunan. Next. Ya, ini untuk komponen utamanya ya mungkin Bapak Ibu udah tahu juga ya. Untuk aksesoris pintu itu ada apa aja? Ada engsel, mortise, silinder, terus ada juga handle dan untuk aksesoris tambahan door closer. Gitu. Next. Dan untuk material yang digunakan, kita udah material stainless steel, ada yang 316 untuk high grade-nya, dan ada 304 di bawahnya, dan ada juga yang 230, itu yang tipe Eco Line. Dan untuk yang 316, itu kita lihat dari komponen nikelnya. Jadi kalau nikelnya dia tinggi, dia semakin bisa menahan karat begitu. Jadi jangan khawatir untuk Dexon materialnya sebagian apa, karena materialnya kita udah yang paling bagus ya untuk standarnya 304 gitu. Next. Nah, itu tadi pemaparan untuk aksesoris pintu dan jendela ya. Itu sedikit saja. Mungkin Bapak Ibu juga udah tahu. Dan itu nanti ada pertanyaan dari situ. Nanti saya akan lontarkan untuk pertanyaannya. Dan next ini ada Dexon Sanitary. Bapak Ibu udah tahu untuk produk Dexon sekarang udah ada sanitary? Belum? Oke, next ya. Ya, jadi Dexon ini mengeluarkan produk sanitary di tahun 2024. Tapi untuk launching atau pengadaan barangnya di seluruh cabang itu di tahun 2025. Oke, ada apa aja untuk Dexon Sanitary? Next. Ini untuk scope produknya ya. Next. Next. Oke, nah ini nih untuk all kategori produknya. Ada shower, jet shower, floor drain, ada kitchen tap juga, sink counter juga ada, terus aksesoris fitting, faucet, sama toilet. Basinnya juga udah ada kok. Next. Oke, untuk sanitary sendiri kita mengunggulkan untuk kualitas, inovasi, dan desainnya. Oke, kualitasnya berdasarkan apa? Next. Ya, ini berdasarkan materialnya. Materialnya untuk sanitary ada brass, ada stainless steel 316, itu yang paling bagus. Ada juga yang stainless steel 304, itu yang standar ya. Oke, kemudian untuk premium spare part-nya, jadi karena kita produknya baru, tidak perlu khawatir adakah spare part atau misal ada kendala bisa dibetulkan atau tidak. Nah, kita udah ada garansinya juga kalau misalnya benar-benar ada kerusakan, kita bisa ganti 100% yang baru gitu. Oke. Kemudian untuk finishingnya kita juga ada yang paling bagus, yang PVD, dan ada platinum seal, itu yang bagus ya untuk chrome polishnya. Oke, next. Dan beberapa inovasi atau fitur yang ada dalam sanitary kita. Itu yang pertama ada airbus, ada 1 million cycle, ada juga nylon jacket, Dynon hose ini yang di selangnya, kemudian ada auto mode untuk jet shower, ada thermal guard juga, jadi untuk materialnya ada yang isolator, jadi nggak menghantar panas. Karena kan di beberapa sanitary ada mixernya ya, untuk hot and cold-nya. Nah kita ada thermal guard-nya, jadi tidak kalau misalnya terkena panas nggak langsung. Oke, ada quick adjust juga, ada neodymium magnetic valve. Ini neodymiumnya yang terdapat pada smart flow drain punya kita, gitu. Jadi ada magnetnya langsung menutup ya. Kemudian ada self cleaning nozzles. Ini pada shower set. Jadi kalau misalnya shower set kan ada pori-porinya atau nozzlesnya ya. Yang kadang air membawa kotoran terus langsung menyumbat. Nah kita udah ada micro darts-nya sendiri, jadi ini sistemnya self cleaning dari showernya itu. Oke, next. Ya, itu sudah. Tadi pemaparannya cepat saja ya. Oke, sekarang ke sesi pertanyaan. Kita udah siapkan 15. Nanti yang jawab mungkin pas istirahat ya. Ini setelah ini istirahat ya. Ya, nanti setelah istirahat bisa langsung ke sini ambil foto bersama saya. Oke. Untuk pertanyaan pertama. Oke. Ini gampang banget. Jadi cepet-cepetan ya. Oke. Dexon ada berapa huruf? Oke, kakaknya di sana dulu. Oke. Bapak nanti aja ya, Pak. Berapa, Kak? 6. Apakah benar semuanya 6? Berapa? Oke, karena ini banyak yang tahu ya. Ada yang berani satu maju mungkin? Satu maju, Bapak jangan Bapak. Satu maju biar cepat mungkin. Nggak apa, bareng saya. Oh Bapak. Bapak. Bapak mau ke WC atau mau ke sini Pak? Oke. Gimana Pak? Oh enggak nyanyi. Dexon emang ada Mars-nya Pak, tapi enggak nyanyi untuk saat ini. Iya. Ada berapa huruf Pak Dexon?
Kan kayaknya 2 itu. 1, 2, 3, 4, 5, 6, 7.
Oke. 7? Benar Pak, 7. Yakin. Oke. Benar ya, jadi ada 7 huruf. Oke, terima kasih. Bapak siapa Pak?
Pak Bambang dari Surabaya.
Oh, Pak Bambang dari Surabaya. Oke. Ya, langsung aja kalau Pak Bambang. Hadiahnya nggak apa-apa. Oke, makasih Pak Bambang. Oh iya, foto. Boleh foto. Oke, makasih Pak Bambang. Ya, foto ya. Oke. Oke, ya, makasih Pak. Ya, selanjutnya Dexon berdiri di tahun ya mbaknya berapa? Oke, ya benar. Oke. Nanti ya dianya ya Kak ya, ambil di sini aja. Oke. Apalagi ya tadi ya? Oh masih yang Dexon Journey. Kantor cabang pertama di tahun berapa? Ibu? 2008. Oke, benar 2008. Oke, ini udah 3 ya. Oke. Oh ya, tadi Dexon selain aksesoris pintu dan jendela udah merambah ke produk apa? Ayo. Bentar. Ulangi. Tadi kayaknya di bagian sana juga ada. Oke, ya 1, 2, 3. Oh ya, tetap sini. Oke. Oke, ACP dan sanitary. Satu lagi, apa lagi? Yang sana dulu. Ya, apa Kak? Apa? Tadi udah masuk sanitary. Satu lagi. Selain aksesoris ini mbaknya deh, mbaknya. Ya, oke benar. Oke, udah 4. Ya, oke. Lanjut. Dexon, 5 products-nya ada apa aja? 5 products dari Dexon. Ayo, tadi. Atau enggak biar cepet, 1 orang 1 atau enggak ada 5 orang nyebutin yang berbeda. Oke, 5 orang yang berbeda. Ayo, 5 product Dexon tadi ada apa aja? Yang keunggulannya, yang biasa Bapak Ibu temui. Clue-nya deh saya kasih. Ada engsel. Selain itu, ada 4 lagi nih. Yaitu 2 lagi. Apa lagi? Yuk, siapa lagi 2? Bapaknya. Oke, 3. 1 lagi orang. Oh, 4. Oke. Dari sini dulu. Tadi ada engsel. Terus apa lagi? Ya, ada closer. Oke, benar. Oke, yang sana? Oke, benar. Ya. Lokes ada apa aja? Apa? Ada 2 lokesnya. Hidrolik. Oke, lockset terdiri dari apa? Tadi. Skip dulu deh, bapaknya. Pak, apa Pak tadi? Oh, Bapak. Gimana Pak? Iya, mortis. Oke, kakaknya silinder. Udah ya. Oke. Oke, udah full. Jadi, Dexon tadi 5 products-nya ada engsel, mortis, silinder, terus sama door closer. Oke, handle ya. Oke. Tadi udah berapa itu ya? Saya lupa sendiri. 9 ya. Oke, lanjut, masih ada lagi kok. Dexon Sanitary itu dikenalkan di tahun berapa? Paling ujung berapa? 2024. Oke, launchingnya? Pengadaannya? Oke, benar. Oke. Terus untuk produk sanitary Dexon itu include apa aja? Ada apa aja produknya? Oke. Saya butuh 5 orang. 5 orang. Oke, sana. Closet. Apa? Faucet apa closet? Oh, mau nyebut ya. Apa? Faucet. Oke, benar. Coba sana deh. Tujung. Shower. Oke, benar. Itu sana. Apa? Kitchen tap. Oke, benar. Ya. 2 lagi. Kakaknya. Jet shower. Tadi shower udah. Oke, boleh deh. 1 lagi. Ya, Ibu. Laundry. Oke. Yaudah 1 lagi aja deh. Masnya sana semangat banget. Sink counter atau basin. Oke, benar. Oke, kayaknya sudah cukup ya. Terima kasih semuanya. Saya Haudra. Nanti kalau misalnya butuh pertanyaan, nanti langsung info aja ke CB-nya. Oke? Ya. Oh ya, untuk hadiahnya yang tadi udah jawab, ayo bisa ke bawah langsung ke panggung. Ambil ya. Ayo Bapak. Oke. Nanti kalau misal yang belum kedapetan, nanti saya kirim langsung ya. Oke. Mungkin ngumpul dulu. Oke, ya. Geser. Mungkin geser. Ya. Oke, langsung aja nggak apa-apa. Nyalur ya.
aja deh, kalau bisa ada di ruangan untuk masalah teknis.
Oke, ternyata ada satu. Satu. Oh, yang belum. Udah semua ini? Udah semua? Ada satu lagi. Ayo, siapa yang mau? Ayo langsung ke panggung. Oke. Ya, tepuk tangan buat semuanya. Ya. Oke, ya. Foto bareng ya.
I'm gonna lead the picture, the photo session. 3, 2, 1. And once again, 1, 2, 3.
Thank you once again to our sponsor, Dexon. And it is now time for our middle day break for lunch and prayer. We will resume the agenda in 1 hour and 10 minutes.
The dining area is prepared outside the plenary hall, and also for the prayer room, you can ask for the committee who stand in front of this room. And also right here in front of us, you can visit the Firo booth during your break. And we'll come back in this room again in 12:45. Directly to the parallel room in 12:45 p.m.
And after the break, we will proceed immediately to parallel session in the room located on the first and second floor. And the organizing committee will be available to guide you all participants.
We once again want to express our sincere gratitude to our generous sponsor who have kindly support HABITechno7, including PT Polimindo Viro, PT Pabrik dan Cat Pasifik, PT Sarana Multigria Financial, dan PT Fajar Lestari.
And we would like to formally close our opening ceremony and the second session of the 7th International HABITechno Conference by saying Om Santi 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 Om.
Wassalamualaikum warahmatullahi wabarakatuh.
Shalom Namo Buddhaya.
Dan salam sejahtera.
Oke, kepada seluruh peserta konferensi, silahkan di luar sudah ada snack dan makan siang. Silahkan langsung bisa ngambil. Silahkan langsung menuju ke parallel session pada jam 12.45 di ruangan masing-masing di lantai 1 dan lantai 2. Terima kasih. Ruang makan ada di luar ya. Kalau misalnya tidak cukup, Anda boleh menggunakan ruang ini juga nggak apa-apa. Silahkan, bebas.
The world keeps changing. Our customer needs evolve and the market shift. Environmental standard rise. So we always ask, how can we do better? This mindset of continuous improvement, whether in materials, design, or performance, is what helped Vital stay relevant over decades.
Ini iklannya berarti ketiganya apa viral? Ketiganya. Oh langsung di manual. Iya.
Kalau si Dida Abi lagi kepusingan soal alokasi rumah dan anaknya yang lagi aktif banget. Mereka sama-sama butuh rasa cekok yang bikin hidup kita lebih ceria. Jadi sumber inspirasi yang berhasil terinspirasi dari pesona
Kan udah coba di nah dia disuruh masuk satu sponsor kan dia award udah coba buka dia suruh login udah coba login dia tetap nggak bisa
langsung beli mitra yang semangat banget buat pindah ke rumah barunya. Ini Arif, sedikit yang perhatian bersama dan suka ekspresi diri. Kalau si Dida Abi, ingat soal alokasi rumah dan anaknya yang lagi aktif banget. Mereka sama-sama butuh warna cat tembok yang bikin hidup kita lebih ceria.
Masuk ya?
Gampang dibersihin. Mereka butuh Metroid Brilliance dari Pacific Paint. Terinspirasi dari pesona Indonesia yang bikin rumahnya jadi lebih asik buat eksplorasi. Gampang dibersihin dan jadi lebih teduh. Metroid Brilliance dari Pacific Paint. Saatnya cerita wajahnya. Saya
Jangan pada sambil
sudah pernah